The Henderson Hasselbalch equation is the log form of our Ka expression. So if we have the weak acid HA and it dissociates into hydrogen ions and our conjugate base, we can write a Ka expression. So our Ka expression is the concentration of our hydrogen ion times the concentration of the conjugate base all over the concentration of the acid. Now we can do a little bit of manipulation with this. If we pull the hydrogen ion out of the equation, we've still got the same thing. And then we're going to take the log of both sides of our equation. So that's going to give us the log of Ka equals the log of the concentration of hydrogen ion times the log of A over HA. Now we're going to take the negative of all of both sides of our equation, and that'll give us the negative log of Ka equals the negative log of our hydrogen ion concentration minus the log of A over HA. Now the negative log of Ka is called pKa, and the negative log of our hydrogen ion concentration is pH. So now we've got pKa equals pH minus the log of A over HA. And if we add the log of A over HA to both sides, we get pH equals pKa plus the log of our base over our acid concentration. And this log form of our Ka expression is called the Henderson Hasselbalch equation. This equation is useful in situations where the concentration of the acid and its conjugate base are known. In other words, if we have a buffer solution. So here's a problem. We want to calculate the pH of a buffer solution using the Henderson Hasselbalch equation. And it tells us that our acid HOCl has a Ka value of 3.2 times 10 to the minus 8. And we want to calculate the pH of a solution containing 0.25 molar HOCl and 0.75 molar NaOCl. So we could go through the whole ice chart and Ka expression and solve for X and take the negative log of that and calculate the pH, and that's okay. But this is actually a shorthand way of calculating the pH of a buffer solution. pH equals pKa plus the log of the concentration of our base over the concentration of our acid. So for this particular problem, we're going to take the pKa value, which is the negative log of 3.2 times 10 to the minus 8, and add to it the log of 0.75 over 0.25. So that's going to give us 7.50 plus 0.48, which gives us a pH of 7.98. And when we look at this value, we've got a higher concentration of the base than the acid in the solution, which makes the pH greater than the pKa value. So anytime we know the concentration of the acid and the base in a solution, in a buffer solution, we can calculate the pH of the solution using this shorthand Henderson Hasselbalch equation. The only issues are we need to be able to identify what the acid is and what the base is in the buffer solution in order to plug the numbers into the appropriate place.